Hi guys, let us do derivation on mean free path. Okay, so let us do the derivation on mean free path. Let me choose the color black. Uh, mean uh, free path. Okay, which is represented by the symbol lambda. Okay, which you would have studied in class 12, right? So let us consider a cylinder. Let us consider a cylinder. And let us imagine there are gas molecules inside this cylinder. Okay. And let us say from the center, the radius is, let us say d. Okay. And let us consider one molecule moving with a velocity v. Okay. Let us consider one gas molecule with a velocity v. So after some time, okay, after time, say delta t, what will happen? Collision should start. So if this is in the path in colliding with this, so this specific distance, or sorry, let me just, let's say this specific distance is nothing but the distance between these two collisions. So distance is nothing but velocity times time, velocity into delta t. Okay. So after time delta t, distance d will be equal to velocity times delta t. Okay, velocity times delta t. Now we are going to consider the volume which we had applied a similar technique when we were deriving pressure derivation. So we are going to consider volume. So volume v will be equal to area times length, right? So area is nothing but pi d squared into length is this, basically this distance, which is velocity times dt, v dt. Okay. Now we know the volume, we know the we have plugged it in, and we can call this particular equation as equation 1. Okay, let us call this first equation 1 here. Okay. So after number of collisions, after number of collisions, let us say capital N as the number of collisions, this will be equal to this entire expression of volume V will be multiplied with N. What is N? N will be what? Number of particles. N will be number of particles per unit volume, per unit volume. Okay. So capital N will be equal to, in the place of V, we are going to plug in this particular step, pi d squared velocity times delta t into N. Okay. Into N. Let us call this equation 2. Okay. Let us call this particular equation as equation number 2. So the theoretical mean free path is given by, you would have studied in class 12. It is the ratio of distance covered. It is the ratio of distance covered, distance covered in time delta t to number of collisions. Number of collisions. Right. This will be equal to what? Distance is nothing but velocity times delta t. Velocity times delta t divided by the number of collisions is this, pi d squared v delta t times n. Okay, let us call this equation 1. Okay, let us call this equation 1. Let me first find the theoretical mean free path. Lambda th will be equal to v delta t divided by pi d squared v delta t n. So what happens? V delta t cancels, and you will get 1 by pi d squared n. This is your theoretical mean free path. So this is theoretical mean free. So now we need to find what is the real mean free path, because we are talking about one gas molecule here, but there are many gas molecules, and when we considered this specific step, we thought all the rest of the molecules are at rest. Okay, so now this will have certain velocity v1, this will have another velocity, let us say v2. Okay, if both of them have different velocities, what will be the real way of calculation? Okay, so how do we do this for other molecules? So you can do a very simple relative velocity technique. So you have to find what is something called as relative velocity, let us say of v1 and v2. Okay, so let us say this is v1, and let us say this vector is v2, and there I'm not taking a resultant vector, I'm taking a difference vector. Okay, let me call that as vr, but it's not resultant. So vr will be equal to v2 minus v1. Vr is equal to v2 minus v1. So vr will be equal to square root, I can write this as square root of vr squared, right? That is vr dot vr. So you can see if I square and take the square root, it's just vr itself. Okay, just writing it in this particular format. Now what we are gonna do is we are gonna write vr is nothing but v2 minus v1. We are gonna put that part here. So v2 minus v1 into v2 minus v1. Okay, so now if you multiply this, what will you get? V2 into V2, right? So V2 dot V2 minus V2 V1 minus V1 V2 plus V1 V1, right? So we can write it in that specific format. Okay, let's write in this format. Okay, so here we'll go one step further. So this can be written as V2 square. This can be written as minus 2 v1 dot v2 plus v1 square. This part you can write it as 0 because they are random vectors. Okay, that specific part you can remove it. So this will be square root of v2 squared plus v1 squared. Here we can substitute v2 sorry yeah, v1 equal to v2 equal to v. Okay, so this will be equal to v squared plus v squared. Okay, nothing but root 2 v squared, or in another way it is root 2 times v. Okay, this is your vr. Okay, this vr, we will just you plug this particular equation in the previous equation, which we had kept it as equation 3. Okay, we'll plug in 3. So equation 3, what happens to equation 3? Equation 3 will be theoretical lambda was given, right? So instead of theoretical, we are trying to find the real value now, right? Real value. So let me take an eraser and remove this theoretical part. Okay. So we are going to find lambda itself. So velocity times delta t divided by what else was there? Pi in the volume part, y pi d square in the place of v there. In the previous step, here in this specific v, we are going to write this as root 2v. Root 2v delta t. Okay. into n. V delta t cancels. So lambda is equal to 1 by pi d square root 2 n, or lambda is equal to 1 by root 2. This pi d squared by n is nothing, or I'll write one more step, 1 by pi d squared n. This 1 by pi d squared n is nothing but theoretical mean free path. 1 by root 2 to theoretical mean free path. Okay. So this is your derived expression for mean free path. Okay. So if you have any questions, ask me in the comments. Thank you and have a nice day, guys.